So just like our prior sections, we've got a better handle on these root functions. Now we want to talk about equations and inequalities involving them. So really, we're just going to jump into it with each of these. The main thing you have to be careful about when you're dealing with root equations is that you have to check your solutions. And that really means check them. Not just check that they make sense in the context of the problem, but that they actually work. Because it's very likely that once we get our equation down, we're going to have multiple solutions, and maybe one of them or both of them don't work out. So typically, if we see a radical within the equation, your whole goal is going to be to get rid of it. So isolate your radical, and then you want to get rid of it. So remember, squaring undoes a square root, cubing undoes a cube root, fourth power undoes a fourth root, and that kind of thing, and so on. So that's our whole goal. Get the radical by itself, square both sides. So we're just going to jump into it. We have an equation here that's involving a radical. And again, this is the thing that is really annoying within this problem. I want to get rid of it. Just like with rational functions, we wipe the fractions to make it something simpler. So what I need to do is I want to square it, but I can't just square these terms individually. That's not how that operation works. So remember, you'd have to FOIL stuff out. Instead, what I want to do is I want to get the radical on its own. So we're going to go ahead and subtract 4 from each side to give us x minus 4 equals the square root of 3x minus 8. And now that the radical is by itself, I can go ahead and square this to cancel it out. But what we do to one side, we have to do to the other. And this is where you have to be really cautious, because we actually need to FOIL this expression over here. Because what this really means on the left is I'm taking x minus 4 and I'm timesing it by itself. And that needs to equal, now I've gotten rid of that radical, which is just 3x minus 8. Okay? So if we go ahead and FOIL that out, our first terms will give us x squared. Our outer term is negative 4x, and so is the inner term. So this is minus 4x minus 4x. And then our last terms will give us positive 16, and that needs to equal 3x minus 8. So we're at a point now, all the radicals are gone, which is great. So I just need to solve this resulting equation. It's a quadratic, and that's typically what it's going to reduce down to. So combining those x's gives us negative 8x in the middle. And now we got to get everything to one side, so we'll go ahead and subtract 3x. And then we'll also add 8 simultaneously. So this leaves us with x squared minus 11x plus 24 equals 0. And really at this point, if you don't get something that factors, it's very likely you made a tiny algebra mistake. Because we need to check these solutions, they should be nice numbers. So this does factor very nicely as x minus 8 times x minus 3 equals 0. So we end up with two solutions, positive 8 and positive 3. Okay? So from here, it seems like we would be done because we have two things or two solutions. But again, we need to check these answers. So I need to plug both of these back into my original equation. Okay? Always has to be the original when we're checking a solution. So we'll start by plugging in x equals 8. So we've got x, which we're replacing by 8, equals 4 plus the square root of 3 times 8 minus 8. That gives us 8 is equal to 4 plus the square root of 24 minus 8. 8 is equal to 4 plus the square root of 16. And indeed, we end up with 8 equals 4 plus 4. This one makes sense. So x equals 8 is a solution to this equation. If we go ahead and try the other one of 3, that would be 3 equals 4 plus the square root of 3 times 3 minus 8. So we get 3 equals 4 plus the square root of 9 minus 8. which gives us 3 equals 4 plus the square root of 1. And unfortunately, this one does not work out. This is not a solution, so this is what is known as extraneous. Really, right from the get-go, we could have figured out that that didn't work because this says 3 equals 4 plus some positive number. I know that's not going to work out. Okay, so we always have to go back and check the answers once we get them. This next one's going to be much harder because we actually have 2 radicals here. But again, you're always going to follow the same process. You want to get rid of the squares or square roots. The only thing that does that is squaring it. The problem is because we have 2 different square roots, we're going to have to do this process twice. So the first thing you need to do is still get one of the square roots by itself, which we're good. We have a square root on its side, and I need to square both sides. So that means I'm taking this side and squaring it, and I'm taking this side and squaring it. And this is where it becomes annoying because on that right-hand side, we do have to FOIL that out. So the left is nice because the square and square root cancel, so we just get 2x plus 6. But on the right-hand side, unfortunately, I've got to take this expression and I've got to multiply it by itself. So really, we need to FOIL this side of the equation. So when we go through and do that, we'll take it piece by piece. Our first term is 1 times 1, so we get 1. The outer term is 1 times the square root, so we really just get 1 square root. The inner is exactly the same thing, so we get the square root of x plus 4. And then for the last term, we have the square root times itself. So when you take something and times it by itself, it's really that squared. So at least this is nice over here. That square root cancels, but unfortunately, we still have more work to do. So we have 1. And now here we have a square root plus itself. That means we really have 2 times the square root of x plus 4. And then for the square root squared, it cancels itself out and it leaves us with x plus 4. Okay. So what we've done is we've gotten rid of one of them, but now we still have the second square root remaining. So it's very similar to this last problem now. I now just need to get this radical by itself and square both sides. So I have a little bit of algebra to do. I can condense some stuff on the right. We have a single x, but then 1 plus 4 gives us 5. And then we've got 2 times this square root. Now I've got to move all the terms to one side to get the square root by itself. So we subtract x and we subtract 5. And that leaves us with x plus 1 is equal to 2 times the square root. Okay. So now we're sitting in a much better spot. I've got a square root by itself, which means I've got to square both sides. But remember here, that square will distribute down to both of these. So on the left, we have to FOIL. We have to take x plus 1 and times it by itself. And on the right-hand side, I've got to square both pieces. So we really get 2 squared, and then we get this square root of x plus 4 squared. Okay. Foiling this expression out now gives us x squared plus x plus 1 is equal to 4 times now just x plus 4. So we've gotten rid of all of our radicals, which is great. We're sitting in a good spot. We just need to solve this resulting quadratic. So distributing out that 4 and condensing those like terms on the left, we end up with this equation. And now we've got to move everything to one side. So we subtract the 4x, subtract the 16, and that gives us x squared minus 2x minus 15 is 0. And now we can finally factor. That's x minus 5, x plus 3 equals 0. We end up with 2 solutions, which are x equals 5 and also x equals negative 3. But again, it's very likely that one of these does not work, so we need to check our answers. So we'll start by plugging in 5 way back up here at our original equation. So let's get rid of some of this stuff so it doesn't look as messy. If we plug this into our equation, that gives us the square root of 2 times 5 plus 6 equals 1 plus the square root of 5 plus 4. So on the left-hand side, that gives us the square root of 10 plus 6, which is 16, equals 1 plus the square root of 9. So we end up with 4 equals 1 plus 3, which definitely works, so this is a solution. Now we have to check our other solution, and it's likely this is going to be our problem. If we plug in -3, this gives us the square root of 2 times -3 plus 6 equals 1 plus the square root of -3 plus 4. So that gives us the square root of -6 plus 6, which gives us a 0, is equal to 1 plus root 1, which gives us 0 equals 1 plus 1. So unfortunately, this does not work, and that is an extraneous solution. So these are the most complicated we can get in terms of having to do this process twice. Wouldn't make you do it 3 times. That would get really messy really quick. But there is one other special type of equation that I want to go over, which is going to be something that's a hidden quadratic. So this one doesn't really have radicals. Yes, I mean, you can turn this into a square root and you can turn this into a 4th root, but this is actually a hidden type of equation. So the key difference to kind of know you're going to use this method is that you're not dealing with the same radicals. In the last examples, we had a square root, even though there were multiple of them, but it's 2 different types of radicals. And actually the thing that's special about these two is one exponent is double the other. So we always like to boil things to something that has x squared dealing with a quadratic, because we know we can factor that, or we can use the quadratic formula. So with this, what I'm going to do is I'm going to pick the smaller exponent between the two, and I'm going to make what's known as a u substitution. So we're going to change this to the variable u. So u is going to be x to the 1/4. So I want to rewrite this equation in terms of this variable u. Now what I can do is if I square u, this would be x to the 1/4 squared. When you take an exponent and raise it to another, we multiply the 2. So this is x to the 2/4, which is the same thing as x to the 1/2. So by making this substitution, we can change both of these in terms of u. So our equation becomes 2, x to the 1/2 is u squared, x to the 1/4 is u, and then we got -1 equals 0. So we end up making a really nice quadratic that I can actually factor. So what I'm going to do is I'm going to solve this equation for u, and then I'm going to go back to my starting variable. So it does factor nicely. We put 2u and u in the first spots. We'll put a +1 and -1 here, and then you can check the outer and inner do add up to positive u. So we get 2 solutions. The first one's a little bit easier. U equals -1. For the second one, this would need 2u to equal 1. So your u will equal 1/2, okay? So again, we've got 2 solutions, but they're in u. Our original equation up here dealt with x, so I have to figure out what does x equal. But that's where we use our substitution, okay? So I'm going to start with our u equaling -1, okay? Using my substitution, u is x to the 1/4. We figured out u is -1, so that's equal to the 4th root of x. And then to be able to solve this equation for x, I raised this side to the 4th and I raised this side to the 4th. So I end up with x equaling +1. So that gives me a solution of 1. Hopefully that solves our equation. Now I'm going to do the same thing with the other solution. We know u equals half. So plugging that in, 1/2 is equal to x to the 4th. And again, to now solve for x, I raise this to the 4th power, which means I do exactly the same thing to the 1/2. So that should be a 4. When I take 1/2 and raise it to the 4th, it's 1/2 times 1/2 times 1/2 times 1/2. That will give you 1/16 equals x. Okay. So we've got our two solutions. We again still need to check that these do actually satisfy the equation. So we'll start with x equals 1/16. Okay. You can use a calculator if you need to, but this is 2x to the 1/2. So it's 1/16 to the 1/2 plus 1/16 to the 1/4 minus 1 needs to equal 0. Okay, make that look more like a 16. So you can plug that into a calculator, but remember these powers we really can turn into radicals. So this means take the square root of x, and this means take the 4th root of 1/16. So square root of 1/16 is 1/4. So we have 2 times the 4th. 4th root of 1/16 is 1/2. Minus 1 needs to equal 0. 2 times the 4th is 1/2. Plus 1/2 minus 1 equals 0. And this does work. Let's check our other solution. We plug in x equals 1. So let's see if we can squeeze it in here. Thankfully, when you take the square root of 1, it's 1. When you take the 4th root of 1, it's 1. So what this tells us is 2 times 1, which is 2, plus 1 minus 1 equals 0. And this one, unfortunately, does not work. So that is not a solution. And we only end up with a single value of 1/16 solving this equation. Okay. All right, so let's try to do our inequalities now. And the main thing to remember, pretty much for anything that's not linear, meaning it's not just x by itself, we're going to have to do interval testing of some sort. So you're always trying to find key numbers. With your quadratic inequalities, it was finding exactly where that quadratic equaled 0. For rational equations, it was figuring out where the numerator equals 0, where the denominator equals 0. So when we deal with the root inequalities, we're going to have a couple key numbers, one of them coming from solving that equation corresponding to it. The other thing that's going to be important is because we're dealing with radicals, and typically they're going to be square roots, we need to make sure that we're only picking numbers that make sense. When we were dealing with the number lines for quadratics, there were no issues because the domain of a quadratic was all real numbers. When we're dealing with the rational functions, you were finding values that caused an issue, and those were key for interval testing. Here, there are going to be numbers that just don't even make sense in the context of the problem. So first and foremost, you want to find the domain of the radical expression that's given to you. Then you're going to find your answers to your corresponding equations, and then those two things are going to give you the right numbers for interval testing. So I'm going to try 2 examples. They're really closely related, and purely so this video is not 45 minutes long, I'm actually using one of the things we've already dealt with before. So x is greater than or equal to 4 plus square root of 3x minus 8. If we go just back up a little bit, this was actually the first equation we had solved, just this sign has been replaced. So it's just going to make it a little bit easier for one of the steps. So first and foremost, I need to find the numbers that make sense in the problem. We're dealing with a square root, so I've got to find the domain of the square root. So always with these radical expressions, we need this expression underneath to be greater than or equal to 0. And going through and solving that, we add 8 This is a linear inequality, so we can get x by itself. Gives us 3x is greater than or equal to 8. And then we go ahead and divide by 3. This tells us x is greater than or equal to 8 over 3. So there are ultimately two ways you can interpret this. If you like the interval testing, 8 over 3 is an important number. But really, we can take that a step further. When I go to do this interval testing, it's not going to make any sense for me to test this interval because I can only pick values of x bigger than 8 over 3. So it really kind of saves you the hassle. You don't have to test this value out. That being said, I'm still going to show you normal interval testing, now knowing 8 over 3 is an important number. Okay. The second thing we need to do is we need to find another key number, and that's going to come from solving x equals 4 plus the square root of 3x minus 8. Right? And so if you were doing a different problem, you would, again, get the radical by itself, square both sides to get rid of it. But we already did this way back up here, and we found a single solution of positive 8. So you always have to check for extraneous because, again, you would end up with a number that won't make sense. So the solution to this equation is x equals 8. Now that I have these two important numbers, we go ahead and we interval test. So our key numbers are going to be x equals 8 over 3 and 8. Okay. So I want 8 over 3, that's smaller, and 8. And this gives us 1, 2, 3 intervals to test. So I will start with interval 1. We can plug in x equals 0. And so what happens here is we would get 0 is greater than or equal to 4 plus the square root of 3 times 0 minus 8. This gives us 0 is greater than or equal to 4 plus the square root of negative 8. And so right off the bat now, you can see this does not make sense because I get values under that square root that are negative. So exactly like I said before, we really didn't even need to test this interval because of the domain of the radical. This one does not work. Okay. Now we move on to interval 2, and I need to pick a number between 8 over 3 and 8. 8 over 3 is like 2 point something, so I could pick 4. Unfortunately here, you're probably going to need a calculator unless you get lucky and pick the right number. And I think this time I actually did. But this would give us 4 is greater than or equal to 4 plus the square root of 3 times 4 minus 8. So we get 4 is greater than or equal to 4 plus the square root of 12 minus 8. So I did get super lucky, and I picked a number that was a perfect square. So this is 4 is greater than or equal to 4 plus 2. And so we find out this interval also does not work. Okay. So we've got one more interval to test, which is interval 3. And so a number that works from there is 9. That gives us 9 is greater than or equal to 4 plus the square root of 3 times 9 minus 8, which gives us 4 plus the square root of 27 minus 8, which will give us 19 under the radical. And so if we plug that into a calculator, it roughly gives us 4 plus 4.4. And so 9 is greater than or equal to 8.4. This interval does work. So we can equal everything in here. But we had to figure out what goes on at the endpoints. And what I would say is just for these specific ones, plug them in to see if you get a true statement. but really because it came from the equation and because of the sign we have, we can fill this endpoint in. But again, you can check the endpoints separately. That would give us 8 is greater than or equal to 4 plus the square root of 3 times 8 minus 8, which is 8 is greater than or equal to 4 plus square root of 16. So 8 is greater than or equal to 4 plus 4, and that indeed gives you a true statement. 8 is greater than or equal to 8. So our solution then just is going to be interval 3. It starts at 8, we can equal it, and then it goes to infinity. So let's extend this one more time. We're going to do pretty much the same thing, but now I'm changing the inequality sign. So we already know the domain, we already know our key number. We're going to utilize exactly our last inequality. 8 over 3 was an important number, 8 was an important number, and this gave us 3 intervals. Okay. So from here, if I try to plug something in interval 1, again, this is not going to work out, but we can plug in x equals 0. We get 0 is less than 4 plus the square root of 3 times 0 minus 8, which gives us 0 is less than 4 plus the square root of negative 8. So this still does not make sense. Plugging in something from interval 2, really let's just go back because the only thing that's changed is the inequality sign that we have here. So let's plug in 4. When we plug in 4, it gives us 4 is less than 4 plus the square root of 3 times 4 minus 8. 4 is less than 4 plus the square root of 4. 4 is less than 4 plus 2. So this one does work, which means interval 2 is good. But I still have to figure out these endpoints separately. And then finally from interval 3, let's go ahead and let's cheat a little and let's just copy and paste what we have here. Because I can pick 9. And again, the only thing that changes is the inequality. It's now facing this direction and we don't have the equal to sign underneath. So this one would end up with 9 is less than 8.8, which unfortunately does not work. Okay. Now we can go ahead and we can check the endpoints to see if those work out. If we plug in x equals 8 over 3, what this gives us is 8/3 is less than 4 plus the square root of 3 times 8 over 3 minus 8. That's 8 over 3 is less than 4 plus the square root of 8 minus 8, which is 0. So that gives us 8 over 3 is less than 4, which is indeed a true statement. So I can fill this endpoint in. If we try the other endpoint of x equals positive 8, this came from the equation, and because we have a strict inequality, I'm not going to be able to actually equal this one. But again, let's just plug it in. 8 is less than 4 plus the square root of 3 times 8 minus 8. 8 is strictly less than 4 plus the square root of 16, which gives us 8 is strictly less than 8. And so unfortunately, this endpoint we cannot fill in. Because it came from the equation, it only works if we have the equal to sign underneath. So ultimately, our solution for this inequality would be 8 over 3, which we can equal, because that number came from the domain, to positive 8, which we cannot equal, so it gets a parenthesis.